Hello friends, this video on oscillations part 15 is brought to you by examfear.com. No more fear from exam. Please make sure you have watched all the videos till part 14 before going ahead with part 15. Now we will study an very important law for simple harmonic motion, which is known as the force law. Till now, we spoke about things like the displacement of the of the particle, the velocity and the acceleration. Did you observe one thing? We could calculate the acceleration of the body executing simple harmonic motion. What does that mean? That means that the body accelerates. Now, whenever a body is accelerating, that means there must be a force which is acting on the body which gives rise to this acceleration, right? That is what Newton's second law, it tells us that force is nothing but the product of mass and acceleration, right? So, whenever you see that a particular object is accelerating, that means there is a force which is acting on that object. Also, when I started introducing simple harmonic motion, I told you that there is a force which acts on the object which always tries to bring it back to its mean position, right? So, this law talks about that force. So, what does this law says? It says that particle executing simple harmonic motion is subjected to a force which is proportional to the displacement and is directed towards the mean position. The second half I have already told you before that this force will always have a tendency to bring the particle towards its mean position. So the force acts towards mean position and this force is proportional to the displacement. Now if you apply Newton's second law, we know that force is equal to mass into acceleration. And from our previous slides, we saw that acceleration of a particle executing simple harmonic motion is equal to minus omega square x of t. Right? This is the acceleration. Now, if we put this value of acceleration in this equation of force, we can say that force is equal to mass into minus omega square x. Or we can write it as minus m omega square x, or this mass and angular frequency. This is represented by a constant which is called k. So where k is equal to m omega square, and this k is often called as force constant. So we say that this force is represented as minus kx, where k is equal to m omega square and x is the displacement of the oscillating particle. This force is often known as the restoring force. This force is called as the restoring force. Why is it called restoring force? Because what does the term restore means? That means to bring back something to where it was present before. So this force also has a tendency to bring the object back to its original position or mean position, right? That is why it is called restoring force, because it restores the object back to its initial position. Now let us look at a few points about this restoring force. Restoring force is proportional to displacement. That is very much clear from its definition, that is restoring force is equal to minus kx. So this shows that force is proportional to displacement. It is opposite in direction to displacement. That is also very clearly indicated by the negative sign. It shows that the direction of force and the direction of displacement are opposite to each other. It is time dependent. That is again very obvious, because since force depends on displacement and this displacement in turn is dependent on time, because displacement is represented by a cos omega t plus phi. So since displacement is time dependent, therefore force is also time dependent. Referred to as a linear harmonic oscillator. Since force is proportional to linear power of x. Therefore, and also it represents a oscillatory motion. Something which oscillates is called oscillator, right? Since it depends on linear power of x, so it is called linear. And why is it called harmonic? Because the motion takes place harmonically. That means it takes place periodically. So often this is known as a linear harmonic oscillator, right? So a particle which is executing simple harmonic motion is often referred to as a linear harmonic oscillator. Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.